Technological solution for rural sanitation. Structures. Abstract. This paper comprises some research features related to sanitation. Potential champions for improving sanitation can be found in every community, as can people with the necessary building and organizational skills. Family members and the local private sector are often the primary designers and providers of sanitation services. These activities contribute to the improvement of the livelihoods in a community. Sanitary officials and public health workers play an important role in facilitating private entrepreneurs and the creating awareness about the importance of proper hygiene and sanitation. It is a major challenge to have by 2015 the proportion of people without sustainable access to safe drinking water and basic sanitation. Only through a considerable increase in the construction and improvement of sanitation facilities within the next 10 years, can the sanitation target be achieved. Keywords: sanitation, organization, toilet. Introduction. The two most commonly used sanitation technologies today are the pit toilet and the flush toilet. Conventional waterborne sewage have proven to be inappropriate to solve sanitation needs in developing countries. The systems are too costly to provide to all, and only wealthier upper and middle class areas are normally provided with those services. Approximately 90% of the sewage in cities in developing countries is today discharged untreated, polluting rivers, lakes and coastal areas. Pit toilets also have limitations, especially in densely populated areas, with severe risks of contaminating groundwater. Within 20 years from insecurity, decreasing soil fertility and escalating prices for fertilizers in world markets, there is a need to utilize the nutrients, especially in human urine, rich in nitrogen and phosphates, for agricultural purpose, thereby increasing productivity and needs for fertilizers. It is obvious that enormous challenge leads to a rethink, a need to raise the status of sanitation and a need for new approaches, techniques, and methods. 2. Problem definition. The present scenario is 30% of villages in Maharashtra are without toilets, having the entire problem listed above. Even though there is a continuous effort toward rural sanitation, either it is viewed secondary or a neglected aspect of life without really knowing the effect of such a sanitation system. Therefore, there is a need that alternative and appropriate methods of designing the rural sanitation systems, like sustainable methods, construction of rural toilets, use of alternative materials, economy, etc. In this context, 2 villages, namely Beldarwadi in Walway Taluk of Sangli district, have been selected for field survey and assess water quality parameters. Further, as a value-added product, vermicompost of cow dung are subjected to urine treatment and sludge of 2 pit latrines. Rational. With the increase of growing rural population in the villages in concern, the unsystematic way of disposal of liquid and solid wastes generated has led to the poor sanitation conditions prevailing, leading to serious environmental degradation and effect on the health of people, especially the health of women is being a serious threat, even though she is the one bringing the growth of the whole family. Therefore the Swachh Bharat mission of Government of India addresses timely both rural and urban sanitations. The mission aims at achieve a Swachh Bharat by 2019, as a fitting tribute to Mahatma Gandhi on his 150th birth anniversary. Further, with the increase in the cost of chemical fertilizers and their non-availability of sufficient quantity and their toxic effects on the land ecosystem, the production of alternative organic manure and harvesting urine energy is being considered as simple and economically viable solution. Objectives: to identify demerits of the existing sanitation structure, to design environmental-friendly and sustainable rural toilet, to analyze nutrient content of byproducts of sanitation waste, to suggest the economical model by using byproduct of sanitation waste, to design the fertilizer from waste, maintenance and overall development of sanitation structures, to give an innovative solution for usage and operation. Scope of study: field study of villages and collection of water samples. Laboratory study of water samples. Laboratory study of vermicompost treated with urine for energy values. Laboratory study of bioconversion of 2 pit latrine sludge and energy values. Designing of urine and human feces separating toilet. 3. Literature review. Human feces are generally fertilized by the simple method of vermicomposting. One of the earthworm species, Icenia fetid, is not able to survive when it introduced with fresh human feces, so modification in physical characteristics of feces was necessary before earthworms could be introduced to feces. A preliminary study with 6 different combinations of feces, soil, and bulking material, vermicompost, in different layers was conducted to find out the best condition for biomass growth and reproduction earthworms. The results indicated a preliminary study with 6 different combinations of feces, soil, and bulking material, vermicompost, in different layers was conducted to find out the best condition for biomass growth and reproduction of earthworms. The result will be found that was the combination of SVFV soil, vermicomposting, feces, and vermicomposting biomass growth, indicating the positive role of soil layer in earthworm biomass growth. However, it seems the soil layer will not much enhance composting rate. Year ago only study with VFV vermicomposting feces vermicomposting assess the average of quality and quantity of vermicompost produced within vermicompost production rate of 0.30 kg cast/kg worm/day. The vermicomposting was achieved by mature low dissolved organic carbon, 2.4 plus or minus 0.43 mg/g, and low oxygen uptake rate, 0.15 plus or minus 0.09 mg O2/g/vs/h. Complete inactivation of total coliform was noted during studies. This was the most important objective in human feces processing. Hygienic quality of feces treated in urine diverting vermicomposting toilets. In recent years, on-site sanitation solutions gets more and more interest. One such new and innovative idea is urine diverting vermicomposting toilets UDVT. This study was evaluated the hygienic quality of the composted material in 6 UDVTs in France. The vermicomposting technology has been explored on a wide variety of organic wastes, including sewage sludge, municipal waste, pig and cow manure and human excrement. Demonstrated the feasibility of using the vermicomposting technology as treatment of source-separated feces. In his thesis he developed a continuous single-chamber vermicomposting toilet. He found that optimal conditions for vermicomposting of feces was at a moisture content of 65–80% at 2025°C, achieving 50–80% reduction in organic carbon after 96 days of treatment. The main question with UDVs is whether the processed material, aside from being stabilized, also can be considered hygienically safe. Numerous reports demonstrate the capacity of vermicomposting systems to inactivate Enterobacteriaceae, such as Salmonella spp, Escherichia coli, and Shigella spp, Contreras-Ramos et al., 2005, Monroy et al., 2009, Kumar and Sweat, 2011. However, opinions differ whether vermicomposting has the ability to destroy or inactivate parasites such as the intestinal worm Ascarisp. Eastman et al., 2001, Bowman et al., 2006, Hill et al., 2013, while little is known about its effect on viruses. In this study, the hygienic quality of human waste treated in UDVs employing epigeic earthworm Icenia fetida that had been in operation between 2 and 5 years, was investigated. Concentrations of Salmonella spp, Enterococcus spp, thermotolerant coliforms and naturally occurring coliphages, used as indicator for animal viruses, as well as physic-chemical parameters analyzed. Vermicompost production rate was found varying in the range 0.230–35 kg cast/kg worm/day with an average value of 0.30 kg cast/kg worm/day. During the study, vermicompost production rate generally depends on the characteristics of feed, environmental conditions, and type of earthworm species. Gajalakshmi et al., 2001, Jain et al., 2003, reported vermicast production of 0.20, 0.29 and 0.20, 0.21 g cast/g worm/day respectively. One of the important advantages of vermicomposting over composting is its ability to destroy pathogenic organisms. In the present, no coliforms were detected in any of the mature vermicompost samples tested, while the feces had an average coliform content of 5.0_109 mpn/g. In vermicomposting, killing of pathogens is prominently achieved through earthworm actions such as intestinal action, secretion of fluids and selective grazing. Composting toilets as a sustainable alternative to urban sanitation. The current water infrastructure in developed countries requires lot of energy and produces quality of potable water for all uses, such as drinking, irrigation, and toilet flushing. In the US, the water and wastewater treatment systems use approximately 3% of total US electricity. Using energy-intensive processes to produce water and then using this high-quality water for flushing toilets is inefficient management of both water and energy resources. Composting toilets require little to no water and can therefore cool 60%. Composting toilets also fit in with today's understanding of sustainable construction since they reduce water and wastewaters, disconnect the toilet from both the water supply and wastewater infrastructure. Such water and wastewater savings can be significant at system level since toilet flushing constitutes the highest percentage of water use in residential, 27%, office, 51%, flows within a building. In the U.S., the most common green building rating system is the U.S. Green Building Council's USC Leadership in Energy and Environmental Design, LEED. Composting toilets are recognized by the USC and they have been used to achieve LEED certifications. More specifically, the use of composting toilets in a new construction or major renovation building can help earn the Water Use Reduction and Innovative Wastewater Technologies credits within the Water Efficiency (WE) category from traditional wastewater treatment plant. The solids obtained from composting toilets can also be used as a fertilizer, yet they would be free from the urban runoff contamination and may require less transportation if they can be applied where compost is produced. Types of sanitation technologies. Sanitation technologies can be water-based or composting-based, Fig. In water-based systems, the flushed water source. Sanitation systems. 1. Water-based, potable, rainwater, or grey water-based. A treatment method. Municipal wastewater, septic tanks, wetlands or living machines. 2. Composting-based, dry, pint flush, foam flush. B. Treatment method. Composting-based sanitation systems are known as composting toilets, dry toilets, biological toilets, bio-toilets, or waterless toilets. They are typically made, ceramic, or fiberglass. A composting toilet has two primary components, the toilet and the composting tank. The other parts of a composting system often include a fan and vent pipe to remove any odor. There is typically a drain to remove excess leachate and access doors to empty compost. Composting systems require little or no use of water for conveyance of wastes. Similar to the conventional toilet, the toilet in a composting system is a waste collector. The waste is collected into the composting tank where it is digested aerobically. Some systems may use vermicomposting as an alternative to aerobic composting. Bulking agents or amendments, e.g. sawdust, leaves, and food waste, are often added to help CO manage different types of waste, adjust carbon to nitrogen ratio, and increase porosity of the compost. Sawdust is a popular amendment because it creates an environment for bacteria to thrive with its high porosity, high water and air retention and high drainage properties. In addition, the low density of sawdust, 0.19 g/cm3. Human urine as a low-cost and effective nitrogen fertilizer for bean production in the whole world. There are many countries uses chemical fertilizers in overdose which attributes to critical environmental and health problems such as chronic kidney disease, CKD. In Sri Lanka therefore a researcher and scientists had decided to finding one of the low-cost effective fertilizers substitutes for inorganic fertilizers in crop production. Human urine is one of the best component for production of such low-cost effective fertilizers which are rich in nutrients like nitrogen, phosphorus, and potassium. This research may be found when human urine is directs used as fertilizers in edible crops production, as low-cost and effective nitrogen fertilizers. The study of urine fertilizer may be conducted in a greenhouse using Bushita bean as crop species. 5 treatments may be made. 1 test 1 Albert solution. 2 test 2 Agriculture Department's recommendation for nitrogen N, phosphorus P, potassium K, fertilizers urea, TSP and MOP. 3 test 3 human urine, nitrogen concentration, adjusted to 20% less than nitrogen concentration T2. 4 test 4 human urine, nitrogen concentration, adjusted similar to T2. 5 test 5 human urine, nitrogen concentration adjusted to 20% more than the concentration in T2 were applied for 3 weeks after planting. After results taken out, T5 results showed highest leaf area, root dry weight and total nitrogen content of leaves. Bean yields was significantly higher, P 0.05, in plants received T1 and T2. Compared to urine fertilized treatments, even though bean yields. 4 key points of research in our project. We prepares a toilet model which included innovative idea about current toilet technology. In our toilet model, we prepares a system which diverges the urine like other matter and human waste, human feces, like solid matter. Due to which we get valuable urine for production of urine fertilizer, which is very rarely used in Asia. The material we are using for toilet could be economical, environment friendly, easily and locally available material. This separation can be converted into usable and nutrient-filled fertilizer which is convenient for use of people in their farms and other related use also. The side walls which supports toilet roof are also made from innovative and low-cost effective material name as play-supply combination of plastic and plywood dust, which has properties of easy to handle, excellent thermal insulation, easy and safe to handle, excellent performance and stability, environment friendly and user friendly. Also, plastply is very cheaper material than comparative to other material available in market for construction of wall. However, usually the cost of normal and simple conventional toilets total construction cost goes up to 20,000 to 22,000. But according to our designed innovative toilets, total completion cost goes up to 13,000 only, which was very feasible to every person in village. Also, it is useful for different government schemes also.